My name is Jennek. I work for a company called OC since 10 years. Canon company. And I've been an MPS user for almost a year now. And after I learned to use it, I couldn't stop.
Nice.
So here I am. This is MPS Anonymous, isn't it? Okay, there's some serious content here. Context and challenge. Approach with some shortcomings. So language engineering to the rescue. We can fix those shortcomings of the approach that was taken to the challenge. Then I have a word example, but given time I may have to compress that, but it's in the slides. Then we are at the point that I can actually explain to you in a more concise way what I mean with normalized natural language. And then I'll show you some MPS stuff, status and roadmap, and learning points that we have so far. So, who has been here last year and seen Ogin Schindler? All of you. So you have seen these printers. We come from office printing like 20 years ago, but these days it's all big printing equipment. And Eugen has told a lot about the modeling that goes on in and around the printer, from embedded software to ink droplets. My line of business is different. It is the software that we create for people working around the printer. Like an operator who prioritizes print jobs, or even a digital artist who would need a preview designing a beautiful packaging carton, whether the artwork actually fits on the carton, or the maintenance people who need to run calibration procedures. That is the kind of behavior that we have to build the system, my line of business. What is the problem that I want to address regarding this software? It is the specification process of product behavior. Now, behavior is not requirements. Requirements is somewhat more abstract. Behavior is a design step that says, if this is your requirement and the product would behave like this, we have met your requirement. And the problem is that when we start discussing those behaviors, we actively document them, and at some point the developers already start developing, and then people lose interest in finalizing the behavioral documents, which is okay, because at the end of the day we will have code. But then when the testers come in, they say what to test against. And when we release this documentation, it's not complete. Nobody trusts it is the as-built situation. And this has been going on for a while, but it's becoming more pressing now for reasons of increased release frequency, more fine-grained components, more variability, and more complexity. So the manual testing process that sort of fixes the situation, taking 2 to 4 weeks for 2 to 3 people who have the regression knowledge in their heads, that doesn't scale. So the mission is replace the manual testing by automated testing. That was the question I got, and I came to the conclusion quite quickly that if you want to do that, you have to fix your specification process in the first place. So that's where we are. The solution is to be found in the outside world. It's called specification by example. It's been going on for more than 10 years. It goes by many names, except in test-driven development, behavior-driven development. But I prefer the word specification by example. And because it is examples that are the core of your specification. Sure, you may want to document your rules, but the test ultimately is a straight path through your decision tables. And this is what it looks like. Given a situation, a state, when you have some behavior triggered, then you are in another state. And there are all sorts of syntactical niceties that you can put in like tables and all. But that's the basic thing. So this is the basic structure of what is called gherkin, given a state. When I trigger behavior, then I'm in a new state. And the other strong point is it's a two-sided text. People can read it. Non-technical stakeholders, like I call them the product people, like product planner, product manager, interaction designer, workflow architect, they can relate to that text. For them it's the specification. But on the other side, you can use this as your test, provided that you have glue code in place. On the right you see some example. One of the lines on the previous slide I've expanded in some clicks on the user interface. This is Selenium. This is how you make it executable, and by making it executable you can run these tests in your nightly build. And we have very fine documentation, which goes by the name of living documentation. So far so good. Another nice thing is that to write this document, you have to bring 3 people together in a room. These are called the 3 amigos. Product owner, developer, tester. In many specification processes, they are not in the same room that often. But we insist together you finalize those scenarios. And the last bit I want to emphasize is it's a 3-phase process. There's a discovery, where you start a conversation and figure out what it is that you're going to build. A lot of informal work styles are helpful here. Then you capture that and consolidate that, which is called formulation, which is the end of the agreement phase. It's the linking pin towards the verification phase, where you need to put in the automation, that's the step definitions, for your nightly verification. So far so good. What is the weakness? Looking at Gherkin as a format and the tools that come with it, Cucumber, SpecFlow, you can enter any text you like. When it is raining and I came in all wet and I started to print it, didn't, etc. That's not what you want to write. Because you get a lot of ambiguity and you get the proliferation of glue code. Somebody might write when the user logs in, somebody else writes when the user signs in. Is this meaningful? So let's take the perspective of the language engineer and look at what we can do to fix that fact that it's free text. What is the language that we want to behind the given, or the when, or the then? And looking at the basic format, it says, given we are in a state, we trigger some behavior, we are in another state. So, function, which is the smallest part of behavior, that's our definition here. The smallest part of behavior you can trigger is called a function. State, those are the keywords. And now you may get worried because you have learned from function programming and function and state don't come well together. Well, there's this guy, Rich Hickey, who invented closure. Wrote a lot about that. It said you can solve that by adopting this model of canon, which says consider your entities as a succession of states which are immutable. And then you have pure functions which compute new state values and you just prepend them. But this is not to talk about the time model. It's just that I'm comfortable with having state and function in one talk. So I stated there are 2 languages here. There's the language where you can express the behaviors that you trigger. Let's call that the language that brings us the functionality of the product. And there's a language that is about state and expressions of the state, something being true or not. And I brought one example, and this example is not from printing because that would assume you would first learn about printing. This is from transferring money. And let's assume we have a conversation with 3 amigos about this thing. Given the balance of my account is 100 euros, when I transfer 10 euros to your account, then the balance of my account is 90 euros. I might have put in what happens to your account, but that doesn't add to the example. And The first line says, the balance of my account is 90 euros. That's the state. Normalize means we bring it into a certain form, and I'll get to that later, so that you can easily transform it or see it as the equivalent in an isomorphic way to something that you could consider code. So I didn't put in transform, I just say codalize, because if you would look at how you would do this projection editing, you could actually think of a different projection on the same model. Actually, such a thing is available in kernel F with the Naplan feature on the invocations of extension functions. And it goes actually the other way. Given that you already have the code representation, you can put union on top, which is fine because business users need it. But I need to go the other way. I need to talk with users who are in the free text world and gradually bring them to what is like more formal, without them being scared, without them giving a tutorial about what functions are in state, by having a natural conversation. And that to me is the process of normalization. So this is what we're looking for. We want to go from the world of like free-form text, have a process that brings us to something which is still text, but much more structured, that then can be subjected to a mapping to something executable. Now, this actually works. I've done this many times before. I worked with MPS. So the challenge for me now is to bring it into the MPS paradigm. So here are some more details on the state language that let me wish here. Just having an expression language is not good enough in this conversation. We also need to flesh out what are the entities, what are the properties, because the expression is something on top of that. So here is the tool. And these are the plastic pieces. I brought the box with me, it's over there. You remember discovery, formulation, automation? The thing you don't do is open the editor and say, now let's have it. Maybe as an analogy, think of how Rembrandt painted the night watch. He did it like this. He started down left, he painted for 2 months, and when he was top right, he was finished. That's how we model. No, it's a different process. You need sketching. This is the sketch of natural language, and it's a domino. And as a moderator, that's my role. This is a moderating process. I would ask questions like, okay, this is the phrase that you want to have in your scenario. Fine. Let's look at the language perspective of it, the domain model. And tell me, how does transfer money work? Where the domain experts would say, well, you transfer money from one account to another. Okay, tell me more. Well, you subtract the amount of money you want to transfer from the from account, da-da-da-da-da. So I put in the words balance and account and amount. Good. And you see there's a sticker right there. Oh, button. Saying to and from, actually there's 2 links between the word to transfer an account, because I've asked the question, are these accounts you transfer from and to are of the same type? Yeah, so that's one block there. Now let's go back to what we have on the table. Interestingly, on the domain model side, on the language side, we say there's 2 accounts involved, but in your scenario you have only 1. Well, domain experts say that's because there's a rule. I can only transfer from my account to somebody else. I wish it were different. That's not a rule. That's not a rule. So let's put it in there. Let's make that consistent. And let's put in the second account also in the percentage of growth. So we're using the structure of the language to fix something in the utterance there. And I've also put in the fact that the domain expert said it's the account from the customer. Let me see how I'm doing on time. So this introduces a new word, customer. Where does the customer come from? And how does this relation between account and customer come about? I always ask about which action does that. What is the verb? So you open an account for a customer and you register a customer, maybe at the bank, but then the story continues. Where does the bank come from? Well, at some point you have to stop. So this is the formulation result, making it more precise. So the original scenario had two expressions, overstate, and it had what we call a function, a trivial piece of behavior, which we expanded into something with, well, the core of that is an action, one or more, but there's rules that you capture at this point. And that also is a composition of expressions, and the action is as we've defined it. So we're actually playing on two tables. We're playing on the domain model table, where we flesh out what can happen in the domain, and we are playing on the function table, what you want your product to do. Maybe somebody wants a product where you can transfer from any account, or maybe a super admin can do that. So on the domain side, this is that's a lot of detail. Yeah.
Can I ask a question?
Yeah, go ahead.
How do you ensure that the two tables you mentioned are consistent?
In the discovery phase, it's just me.
Okay.
In the formulation phase, it's MPS.
But you could have behaviors in the table that describes the functions that you never exercise in the scenarios.
When the formulation is approaching completion, we can only write down stuff in the functions that has been declared in the domain model.
Yeah, then I used the words wrongly.
Yeah.
How do you ensure that there's nothing in the domain model you don't use in functions and scenarios?
Or the other way around?
The other way around, because
Yeah.
the way
So,
over is clear because you can't even write it.
good point. We don't have a check on that yet. So there may be dead parts of your languages that are there and not used. Yeah, that may happen. That may happen all the time. Right. So this is my inspiration. The one guy on top taught me about knowledge elicitation and the domino stuff, and the guy on the bottom taught me about the functional interpretation of that. So here we are with the process in much more detail. And normalization is an active process. It's moderated, it's a team effort. You have to have the three people together because it deepens their understanding. The beauty of it is that I've developed a format that I don't need a tutorial. We can just start. And the moment you need a new phenomenon, the case is on the table. And say, freeze, 5 minutes of explanation. This is how we model it. Let's move on. So this works nicely. I've been doing this for 20 years now, more or less. But only for 1 year, bringing it to. Okay, let's look at some tools. For the discovery, we've seen this. This is the table we are sitting at with the 3 amigos. The beer is under the table. This is where MPS is. MPS is the single point of truth. And we generate artifacts back to the review process. People want to review in Word. It's not my preference, but at this point I don't want to fight over that, so I'll just generate Word. And the other way is we generate tests. We don't generate code, we generate tests. And the reason is that testers are far more easy to embark on this process than developers. So developers will come, but first we work with testers. So we generate from one source to multiple test frameworks for various reasons. There's a lot of interesting stuff going on here, but that's for another time. Well, I've worked with the paradigm a lot already, but that's not important. What's the status? Status is fake it till you make it. When I was asked to fix the specification process, I ran a pilot, I outlined all of this. I had my Word document generated by me at night, typing a lot. I was this model checker. And everybody loved it. So I got funds to scale up. And the good part of it is I already knew much better what are the real requirements and where's the real value. Much in line with Collier said this morning. Same with generators, but I fixed that one earlier. Because me sitting in the middle, I knew what hit me most, having not a diva model, and that was on the code generation side. So we are evolving there, and so we created, principally what we have now is generating target languages for Word as well. I've put it on GitHub, so you can have a look at it. And only then we will deepen models. So this is a view of in the spirit of plain text gem, this is docx, which together with the DSL Foundry people will be publishing further. Scenarios, I fully implemented Gherkin, so the generators work from there to robots, SpecFlow, karate, and whatnot, protractor. Actually, the domain model thing is pretty much complete. You see it here. And this would generate in Word, and you see the embedding of the Gherkin stuff in here. That's all familiar territory. Last minute is on lessons learned. On the specification side, I got 3 quotes. The product owner said, "At last I feel I'm in the driving seat. I'm now confident that whatever I say on this table will actually get built and tested." He was the first to grasp the process. The tester said, "Now I can start building my tests way before the code is done." Normally they were in the critical path because they could only look at the code and build the test later on. And the developer said, "It's intriguing that the language that we came up with is precisely the design I did a long time ago." And then the other 2 got mad, said, "You sorted all this shit out and didn't share it with us?" The developer is still not on board. On the verification side, there's more expectations than actual experience. It says, "I expect that we reduce the amount of blue code massively, get it, come to grips with it, and we can generate more and code less." All right, that's it for me.
You didn't say it, but it said on the slide, develop a predicate language on top of kernel F.
Yes.
What do you mean by that? And do you need commit rights so you can open source it?
Yes.
Okay.
That's the second question. The first one, what do you mean by that? When I think of expression languages and look what I need, almost everything is already there.
Yeah.
Maybe for one thing like the discriminated union, but then we don't.
Okay.
Yeah. So it makes a natural extension, and I would love to see that the not long thing in kernel F sort of gets stretched to somewhat more applications. Because, okay, my interest is in going from the free-form text to that, but going back is equally important. The moment you have that structure and you want to have different views of natural language, I think more people might benefit. So maybe there's a common interest there.
I can't put together what you just said with the word predicate language.
What's the thing that bothers you?
No, I just don't know. What do you mean by predicate? Because what you just
Predicate
explained,
language are free expressions that end with a boolean.
Okay, I see. Okay.
It's,
For me, a predicate is a boolean thing, you know.
yeah, indeed it is. But you could say the account of my aunt has more than €100. So there's a lot of dot expressions on either side, but at the end there is a boolean thing. So that's actually a free expression language. over the things that you find in the domain model.
Students don't understand that we should take this offline, I guess.
Let's do it, yeah. Anyone else? Okay.
I'm very amazed by your language. Is this the natural Spark that also the text department is using?
Not from a historical point of view, that's totally unrelated. The question was, is my work related to the regelspraak stuff from the Dutch tax office?
Yes.
It's from a historical point totally unrelated, but from a substantial point of view, I think there's considerable overlap. So we might look at that and see how we can benefit from that.
Because I'm very interested for different languages. I would like to have it in German.
Mm-hmm.
And to propose for our procedures in the project I'm using, I'm working on.
So the question I sense is that would this work for other languages than English?
Yeah.
It works for Dutch, I can tell you. I've tried that. But then they're in the same family. Whether it would work for Finnish or Japanese, I can't tell. But there's this theory about general linguistics that says that there is a common thing in the grammar. Every language has nouns, prepositions, and there may be separate words that go into one of the other ones. But the mental constructs are the same,
Quite similar.
according to Chomsky.
Yeah.
Okay.
Can you please go back to slide
32. That's very precise. There's more than one. Yeah.
Like at some point you said, I think it was a slide before 33, so I guess. Yeah, you talked about generating. Yeah, this one.
Correct.
Yeah, you talk about different tests, but I and you said you don't have it in there, so you have but could you quickly like say
The reasoning is like this. We describe product behavior that is observable from the outside. Surely that you can observe from the web UI or any other UI, because that's where the product ends and the user begins. But in many architectures we find you have the same behavior on the web API level. If not, there's business logic in your client, and you really want to think twice if you want that, because it's not testable or it's not shareable. The moment you want to publish your API, that part of behavior is not part of that. Same reasoning between your web API and then the middleware, and then we have your business DLLs. Typically, the middleware will do the authentication, but nothing else, please, because it will get in the way of testability. So we have, as a rule, that a product scenario should be applicable to all three levels. And this saves a lot of testing, it makes your test environment much more healthy. But it takes rethinking from the architects. They would happily put some business rules in the client. If you would never migrate your database, those are the rules that you will not check at that point in time, because they were not on your server side. The best you can do is duplicate your behavior. But you can cache data, you can cache behavior in the client, but it's just a copy. Time's up.